Good afternoon, everybody. Welcome. Our next speaker is Hugo Talbot to talk about simulation open framework architecture. Give him a big hand, please.
Thank you very much for the introduction. So yeah, I'm going to talk about SOFA. So SOFA is for first originally from research, and then you'll see it become a bit wider than research. SOFA is a multi-physics engine basically that we are using with emphasis for medical application. We'll see that it can be used for actually any kind of physics simulation, but that's the main purposes. It's open source, so there are like many things here at FOSDEM, and I'll tell you a little bit about the story of SOFA. So it started about 2006 in Boston, MIT, where a French researcher had this idea of creating a platform, open source platform for globally physics simulation. He came back to France, and then at INRIA, which is a research institute for computer science, he came and started developing this platform in collaboration with 4 different INRIA teams. So they worked during 5 years together, all those 4 teams, and then more and more companies and startups started looking at SOFA and having interest to that. So now there is a quite big community made from research institutions, universities, and also companies. So what is SOFA? So it's making physics. We'll see that just right now, what kind of physics it's doing, but how it is organized. So there is a main core, open source, that anyone can download, use with a LGPL license, so it's quite permissive. And then all around, it's why I wrote modular because you can build then your own plugins and any kind of, your own module in which you're going to develop new classes, new models to create your own application. And what is that useful? Because you can put any kind of license you want on your own code. So basically you can develop a product or make your own research, private or open source, based on SOFA using that kind of plugin architecture. It's multi-physics. That's what we're going to see just right now. And we are always targeting at interactive simulation, so pretty fast simulation of physics. And you can see that at our booth in the building, in Building K. We have an haptic interface showing a small demo with SOFA. So what is SOFA? I said it's RGPL. You have this plugin system. So all the usual stuff. So building with CMake, we are on GitHub as well. So just like it has been discussed previously, and 2 dependencies which are Qt and Boost. We are cross-platform, so you can use it on any kind of platform you want. What it is doing for physics? So for physics, there is usually, from the origin, we were really focusing on mechanical simulation. So mechanical simulation in medicine, it was mainly, how does an organ behave, or if you push on the liver or on the brain, how does this organ is going to respond? So it's a bit of butchery, but basically it was what it was made for at the beginning. And then we started looking at more than just mechanics, but we looked at fluid dynamics and also some kind of other field simulation, which is here electrical field, could be also temperature field, so thermodynamics. And all those stuff are available then in SOFA to make your own simulation. I mentioned, it's C++ classes, but if you want to build your own simulation, you can use either XML or Python scripts to then describe and run your own simulation. So yeah, some kind of butchery, that's the kind of example we are doing. What is the use of all that? We are using usually, medical simulation, so physics simulation in medicine for making training simulators or helping at least surgeons, during the operation, bringing new tools based on simulation. Again, you can join us at the Building K. You'll see a lot of different videos and so on. So how does it work to build a simulation? All these, each C++ class build what we call the component. Here, each one here is a C++ class. And then each component has a role. Of course, you're going to have a solver. You're going to have, if you want a mechanical simulation, you will have a mechanical law describing how does this object deforms, a mass, and so on. Basically, all the physics. And this is described as a graph, so a direct acyclic graph, as we said. Each node has I mean, each component in this node will have, parameters. If you take the mass, for example, the mass, you need to define the mass density, or at least the total mass of your object. So that's how it works. And this scene graph will be described using using XML scripts, or Python scripts more recently have been introduced. So one thing which is very powerful about SOFA is that it's not only physics. You have also visualization. You have some algorithms for collision detection. But how does that, how does all those different models? You can have one model for the visualization, one model for the physics, one model for the collision detection. So let's. Oh, do we see? No, we see nothing. Okay. And we see even less nothing. Does that change here? No, nothing. Okay, so the idea is that if you want to, I will summarize basically all those different stuff. Here you see a little bit. That's a lever, a human lever. So the idea is the power of this multi-model representation. What it is, you can have different topology for representing the same organ. One will be here. It's small cubes, on which is going to be computed the mechanics. So the mechanical simulation will be computed on hexahedron. And here you can have, for example, collision detection. You can use, instead of cubes, to be more realistic, maybe you want to use a triangulated surface. But then you have two different objects, one for the collision, one for the mechanics. You can have here for the visualization, you see nothing, so it's really very nice for visualization. But the question is then, okay, you can have all those different models, that's cool, but how do you relate them? That's what we call a mapping. We have mapping, making the correspondence between the mechanics, the physics, between the visualization that can be different, or the collision. Globally, what you need to, what is needed here to understand is just that what it allows to do is to set exactly the power of computation where you want. If you want to have a very accurate mechanical simulation and a crappy visualization, it's possible. If you want to have the inverse, a crappy mechanical simulation because you don't want to be accurate, and a very, very nice, with a super nice textures simulation, it's also possible because the two models are completely independent to each other. But then the mechanics is gonna, manage. It's the master, and the visualization is gonna be the slave. And then you will have a very nice simulation with a nice visualization, even if the mechanical simulation is very simple behind. So you have some other features in SOFA, just like GPU computing, which is possible. There is a plugin allowing for using the GPU of your computers. You can have and you can couple any kind of physics simulation with haptic device. That's what we have at the booth. That's what you can see here at the video. You have a physics simulation. Okay, cool. It's running in real time. But on top of that, you can directly interact with the simulation. So here, the tools are, there is an interface between the haptic devices and the simulation, and therefore the user can directly, use the tool and got exactly the feedback is interacting with a real object. Everything is virtual, but it's going to have some haptic feedback. So you can also couple the virtual with virtual simulation with some haptic and interface devices. Many other stuff. So there is, I said you can create new plugins, adding new features to SOFA. So for example, you have something which is dealing with medical images. You have something about registration, changes of topologies. For example, if you're cutting an object, you have to update the topology. So update what the geometry basically of your objects. That's available also in SOFA. So now there is a consortium. I told you it started in 2006. There was researchers and so on. Now there have been some companies, startups that has been created as well. So we built a consortium so that also single developers, companies, researchers are basically happy with what is going on. And we are providing regular releases of SOFA. That's what we are doing. And we are taking care of promoting SOFA, and basically, for example, if there is any single developer using SOFA, making his own application, we are also here to promote his or her work around SOFA, find partnership, and talk to the open source community. So yeah, there is a website. On this website, a forum to ask questions, to start with SOFA. There is also tutorials, videos on SOFA where you can see the different kind of application examples that you can achieve with the platform. And so that's the different members that are joining us for the last 4 months. So it's a pretty young consortium, but it's still growing. And here are all the stuff that you should remember is that it's on GitHub. So if you want to see and discuss about the code, it's on GitHub. So SOFA Framework. There is a YouTube channel, SOFA Framework, as well, where you can find all the videos and achievement of researchers and companies. So Twitter, of course, and then the forum where you can ask questions and really get started with SOFA. So just what I can tell, so as it's open source, as many things in FOSDEM, you can basically download SOFA, give it a try, make your own experience with it, give us feedback about that, and also create then your own application. My job is also to make so that any kind of application created with SOFA get an end user and get promoted. So do not hesitate to use it. Ask questions on the forum. You can also contact me directly per email. And do not hesitate to come at our booth. So we are at K2 and booth number 17, sorry. 15 is maybe cool as well, I don't know. And yeah, there is a small live demo and other videos to show what kind of achievement you can do with SOFA. So do not hesitate to join us. I would be happy to talk with you. So thank you very much.
Thank you very much, Hugo. We still have a couple of minutes left, so if there are any questions, just raise your hand and I'll get the mic to you. There I see one.
I have a question. Do you use a finite element formulation or any other type, or do you have many different types?
Yeah, for the approach that it's chosen, it's mainly a finite element method. There is also some SPH approach, MLS approach that has been implemented in SOFA, but very few on grids. Grid simulation has been very naturally considered. That could be interesting for only thermal simulation, but mainly FEM simulation.
So any other questions? Well, then I suggest we wrap up. Hugo, thank you very much.
Thank you very much.